Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno, and I'm so freaking excited because right now I have Donna, Program Manager of Azure Functions, which, besides Xamarin, is my favorite product that we have at Microsoft.
Awesome.
I've said it multiple times to a lot of people, but Azure Functions, it blew my mind the first time I saw it, the first time I used it. I used it this week to set up like this whole cool Slack integration craziness thing, and I'm so excited to have Donna on to talk about Azure Functions for mobile applications. Now, people may not know who you are, Donna, so maybe introduce yourself a little bit.
So I'm a program manager on the Azure Functions team, as James said, and I'm responsible for the developer experience, which is the Visual Studio tooling and the portal experience. So basically, what I'm going to be demoing today is what I work on.
Awesome. So maybe people don't know what Azure Functions are, because I think that was always the hardest thing for me, is trying to wrap my head around, because everyone kept saying serverless compute. So maybe can you tell me what is an Azure function?
All right, well, first let me explain what serverless is. If you're like me, when you heard the term serverless, you're like, well, that's a stupid word.
Yeah. You're like, wait, there's no servers, and what am I going to run it on?
And then the light bulb moment for me was when one of my colleagues said, hey, no, it's like wireless. Wireless, there are wires, you know, in the router, in the access point, but not for you as a user. For you as a user, there aren't any servers. So serverless usually means three things. Number one is it's an abstraction of servers. So your code runs somewhere for usually a short period of time, like 5 or 10 minutes, and you don't have a machine that you could even remote into or look at. You could have one execution run on one machine, another execution on a completely different machine. So that's completely abstracted from you. The next thing is that it's event-driven and it scales based on events. So that's really important. So an example of an event is a timer. You want to run every day, every hour. HTTP triggers are also events. And then another common event is queues. And the cool thing about things like queues is that the service can look and see how long the queue is, and then add more instances if you're not keeping up.
So kind of like insta-scale,
Exactly.
if you will. It
scales even faster than app service for HTTP and things like that. The final point is you pay for only what you use. So let's say you have a function that runs every day for 5 minutes. You do not have a VM except for those 5 minutes, and you only pay for those 5 minutes.
Oh, I like that. Yeah, because the problem is, like, when I set up a backend for my application, I got a SQL server that's always running. I have an app service that's always running. I got to pay for both of those, and I can't turn them off, because what if someone goes to my website?
Exactly.
Right. But with the function, you're saying it's alive while it's running. So it turns on and turns off.
Exactly.
Is there overhead with that? Like, does it have to? How long does it take to?
So that's a really good question. So that's usually called cold start. Cold start is the time that it takes for the function's runtime to start up when no instances are running. And right now it's in the 5-second range, but we're doing a lot of work on that to have these kind of instances around that are like placeholders, and then we'll inject your code dynamically. And we're seeing times in about 2-second range. And we're going to improve that further, because even 2 seconds for a webhook might be too long. But we're constantly improving that there.
Now, how do I pay for it? Do I have to, I go and I assume I can go into the portal and there's a bajillion options and there's a function in there. Is there anything that's unique? I'm used to like paying for app service where I have to like pick a plan and stuff like that.
So that's a really good question. Let's go to the portal.
Let's go to the portal. Let's hop over to the machine.
Let's take a look at what the create experience is like. So one of the interesting things about Azure Functions that's different from every other serverless vendor is that we have 2 different ways that you can run a function app. You can either run it on the serverless plan, which is the default. That's the consumption plan. So to create a function, you go to compute, and then you create function app. And what you'll see here is the usual fields that you usually see. Here, there's a hosting plan. And there's 2 options. There's a consumption plan, which is usually what you want. About 75% of our customers use this. Or you can use an app service plan. If you choose that, you can even pick one that's used by your website. So if you have an app service plan that's underutilized, this is a nice way to get it, basically functions for free.
Oh, so like I have I have a mobile app right now that is connected to a SQL server, and I have a little, website that's running. It's essentially just doing the gets and sets for my mobile applications, online, offline sync.
Sure.
So I can just leverage what I'm doing because I already have it there.
Yep, exactly.
Now, does that mean that mine's always on then if I pick one?
It is. By default, it will create an app that's similar to a web app with a different resource, function app type, and it will set always on for you.
Got it.
And that's how it processes the triggers.
Got it.
Now, when you run on a consumption plan, we have a central multi-tenant service called the scale controller. And that's the thing that's looking at all your triggers and deciding whether or not to wake up your function app, and whether or not to scale you out, and whether or not to turn off instances.
Got it. But you said most people use consumption, because that's really what's unique, right? Is the idea is that if it's just sitting there, I don't really want to pay for it, right? So you would never really use unless you needed it to always be on, but the idea, I'm assuming, is that, hey, I have something that runs every night at midnight to clear out my database. I probably don't need to pay for the other 23 hours, 59 minutes, right?
Exactly.
And is it cheap?
It is very cheap. So we are not, our goal here is to make it really easy to use other Azure services.
Look at all those zeros in there.
Yeah, exactly. So there's actually a free grant across your subscription. You get, so we have a unit called a gigabyte second. Which is new. Now Azure Container Instances also use this. What it means is how many seconds are you running and how much memory did you consume?
Got it.
So unlike some other vendors, another aspect that's really unique to us is that we dynamically figure out how much memory you need. On Lambda, for instance, you have to figure out up front, do I want 128 megabytes all the way up to 1.5 gigabytes? And we have that same top limit, but we figure out for you. And we found that customers were over-provisioning. We originally had the first model. We found that customers saved about 75% by having the platform figure it out for you.
Oh, got it. Yeah, so everyone wanted to give us all their money. And like, hey, we don't want your money just yet. Like, we can just literally give you tons of stuff for free and actually scale this up for you.
And plus abstract it more. Because if you have to pick memory, that's not so serverless, is it?
I don't want to. One time I spun up a Linux VM and I was just like, well, there's like a bajillion options.
Right.
I figured out which one I needed, but it took me a while.
Exactly.
What seems what's nice is you can go into the portal, function app, boom, you're up and running in a few seconds.
Exactly.
What I love about functions is that I can write stuff in CSharp.
Yes.
And as a C# mobile developer, it makes a lot of sense that there's stuff for mobile apps. But what else does it support?
So we also support Node.js, which is another one of our first-class languages, and also F#. And then we have a few languages that are preview or experimental, such as Python. We have PowerShell. Actually, that's very common for automation scenarios and that kind of thing.
Very cool.
And we're going to light up new languages soon, so stay tuned for that.
Cool. So basically, if you have some code, you can run it in a function.
Exactly.
That's the goal, right?
Exactly.
Yeah, cool. Awesome. So what are mobile scenarios? Because you talked about queues and HTTP triggers. In the mobile landscape, what are you seeing developers use functions for?
So HTTP definitely. Like you always need some kind of a backend. This is like basically the lightest weight backend you can have, which is a good fit for mobile applications because you often get very spotty traffic and not very frequently, especially if you're doing something like offline sync, like you mentioned. So you can have just an HTTP endpoint that you authenticate against. I think you even had a blog post about that when we were in preview. So that's a most common scenario. Another one is that you want to do background processing, and you don't want to do it on a customer's device.
Got it, yeah.
So for instance, you upload a photo. I'll show a demo of that. And these cameras on phones are amazing, right? They're huge, huge photos. They give you like 5 megabyte photos, which is not great for downloading. So you could have an image resize function, which I'll demo, where as soon as a photo goes into blob storage, it triggers and then it resizes it, which will make it much more mobile friendly. That's
nice, yeah, because I often have, and one of my plugins, right, is taking a photo, you upload it to blob storage, and you're like, oh, I got to go write all this stuff, or I have to try to process on no one on the phone wants to wait.
Exactly.
So the idea is just like offload. Now, can you use any package? Like, how would you resize the photo? Or
yes,
can
you
use
can use any NuGet package at all. So and I'll use the image resizer, which I like, but there's a few others that work just fine.
So if I'm uploading images or text, if I can use any, because can I use like cognitive services and OCR stuff?
Absolutely.
Oh, cool.
So basically anything that you want to do in Azure is now available to you with this pay-per-execution programming model.
Well, and then I guess the nice thing there is so since the logic doesn't run on the phone, if once I upload a photo, my image resize could be, I could do whatever I want afterwards, right? Like I'm no longer limited to just on the device.
And you're not limited to that short response time that you want to provide users on a phone.
Got it, cool. Yeah. Well, let's see it. I'm ready to see some demos. Let's hop over.
Okay, so what I'm going to do is show you the Visual Studio tooling. Let me just show you real quick how to get to the installer and everything like that. So you go to Documentation, and if you scroll down, you'll see that one of the top things here is Serverless Functions, because we are one of the most popular services in Azure. We're growing very quickly. We only GA'd in November of last year, and we're seeing huge growth because of the simplicity of use, the ease of using other Azure services.
Nice.
So there's under Quick Starts, there's Create Function Visual Studio. Currently, it's available in the preview channel with Visual Studio Preview 15.3, which is basically VS Update 3.
Got it.
Which is going to be GA'd very soon. And so once that happens, it'll all be included in the Azure workload.
Nice. Even maybe by the time this is out, we'll see.
Yeah, that would be awesome.
Yeah.
In fact, you'll go to this page and maybe it will say something different. So the tooling experience is going to be very similar. So what I'm going to do here is show you just the new function project dialog. So basically, you just go into Visual C#, you pick Azure Functions, and you get a project. So what that project includes is a file called host.json, which is going to be empty by default. This has a bunch of configuration settings, like how quickly do you want to process queue messages? Is there a timeout for queues, and a lot of advanced stuff like that. But it's here for you to edit very easily. Then you also get a local settings file. This is used only on your local machine. And you have to set a value for Azure Web Job Storage if you're using any triggers other than HTTP.
So you're saying that I can write an Azure function and I can test it locally on my machine. I don't have to put it in. I don't even have to have an Azure account at this point. I can just.
Yes. If you're using HTTP, you don't even need an Azure account. If you're using one of the other triggers, you should add a real Azure account.
Got it.
So that's how it works. And then if you want to add new functions, you just say right click, add new item, and add function. And these are the same templates that you see in the portal. All configured for C#. So I have one function I want to show you, which is for image resizing, which is very common in mobile applications, as we were saying. So what you'll see here is something interesting, and this is specific to our C# programming model.
Yes, I see you have the same host and local settings.
Yes.
And then you have this resize image.cs. So it's just a C# file.
Exactly.
Oh, okay.
So I'm going to create a DLL and upload that. And that's going to be more performant because when you use scripting, every time the host restarts, it needs to compile your code, which adds to your cold start. So it's just going to be a DLL, load it,
execute it, done.
Exactly.
That makes sense.
So you use attributes to define your function. So you put this function name attribute on any public static method. And then you put your triggers as attributes as well, which is convenient because you get to see exactly what's going on.
Got it.
Now, you don't even have to hard code these values. If you put percents around them like this, it will read those values from a local environment variable, either in Azure or locally.
Oh, got it.
So even though your config is in your code, part of your config is in your code, you still have a lot of flexibility.
Got it.
So what this is doing is it's saying whenever there's a new blob in the sample images container, let's give it the name in curlies, and we're going to have two output bindings, which are going to be the small and medium version of the image.
Perfect.
And so see how we're using name again? That's because it comes from the previous one. So whatever it triggered is going to have that value. So then we're just going to use image resizer. Now notice this code. Like I am not using the storage SDK at all, even though I'm using storage. And if you look at my usings, I have a few usings. No references to storage, which means it's super easy to get started. You just use streams. So I'm just going to write out to a new stream.
And it just knows that this was output to a blob because there was a blob trigger, and these are blobs that are being output.
Exactly.
Whoa, cool.
So this is the power of binding. So it's that easy to consume other Azure services. So there's bindings for Service Bus, StockDB, or Cosmos DB now, and all kinds of other services. So
I take a photo, I upload it to blob storage, and boom, it's resized in literally 4 lines of code.
Exactly. Exactly.
That's crazy.
Yes. So let us set a breakpoint and see how this is working. Let's actually do it on the last line of code after it's done everything.
Okay.
So let's just F5. And the one thing that I had to do here is I mentioned that local connection string.
Yeah.
So if we look at local settings JSON, what we'll see is that I put in my storage connection string, which I got from Storage Explorer.
Got it.
So we can see the host is running. So this is the container, and let us. So I figured since this is Xamarin, I should have a Xamarin themed photo. So let's upload this image. So this is a very large image of monkeys, which are just adorable.
Adorable, love it. I may have taken that photo.
Awesome. And so we can see here it's 250 kilobytes, which is actually pretty small.
Yeah.
But the dimensions are pretty big. So now we can see we set a breakpoint and the function ran. If we look at our other containers, we can see the same file name, and the medium one is only 65K, and the small one is 44K, and the dimensions are a lot smaller.
Nice.
Means that you can put it in a mobile app more easily.
Yeah. Yeah, and also you can then scale based on your device type.
Absolutely.
Like, oh, am I on an iPad? Well, I want a higher res photo, but I'm on an iPhone. I want a lower res photo.
Yep, you could dynamically control that.
Very cool. Awesome. So literally just a few lines of code, up and running, and then this is that server storage explorer, which I use all the time, which I love. Very cool. So image resizing. What else can we do?
Do
we have any like more
Yes,
complex
let's do something a little bit more complex. So here I have a website. I haven't created a mobile app in a while, so that's why it's a website and not a mobile app. But what it does,
could be a mobile
it could be a mobile app. In fact, audience, I challenge you, the first person, or actually anyone, to take this sample and add a mobile app for it. We will retweet from the Azure Functions Twitter account.
There you go. Very cool.
So what this is a site that sells cat products, and customers can upload photos of their cat using the product. Now, this is customer content, so people are going to upload all kinds of offensive things, like photos of dogs, for instance.
Yeah. People are great, but sometimes you may pick the wrong photo.
So we can't just show everything willy-nilly, and human moderation is time-consuming.
Got it. Yeah.
So what this site does is, whenever you upload an image, I'm going to pick this adorable photo of my cat. It's my cat, Moxie. Whenever you upload a new image, it uploads the photo to blob storage, and it writes the review text to DocumentDB, Cosmos DB, and it sets the status to pending because it's waiting for the function to execute. Now, the function only runs on my local machine, so right now it's still going to be in that queue. So let's look at the queue contents here. So the contents are not super interesting, but just notice there's two fields. There's a blob name and a document ID.
Okay, so there's actually the blob image and then the document, which is kind of the status, I assume, and then also the this is my cat Moxie.
Exactly. Okay. So now what we're going to do in the function is we're going to bind to those parameters. So this is one of the coolest features of functions that I love. So here, notice I'm using percents for queue name. If we look at our local settings file, we'll see that I've set the queue name here. So you can even customize what queue you're listening on.
Oh, cool.
And then this is where that blob, so basically here I have curly, in curly's I have blob name. The reason that works is I have a POCO that I've defined called review request item.
Got it.
So it automatically gets serialized into this type because that's what the payload looked like in JSON.
Got it.
So I have a document ID and a blob name field. Now I can use those properties in other bindings.
Oh, cool.
So here I have a stream that is bound to the actual blob that was the ID in that queue message.
Oh, cool. Nice.
And same with the document ID. So without using, again, I don't have to use the Cosmos DB SDK. I don't have to use storage SDK. All the data is there for me.
Makes sense. Very cool. And then if you had any other custom data, basically in that, you would create that little data structure that you would put. So
exactly.
And
it would automatically get serialized. So let me show you what this function is doing visually. So I wrote, as a hackathon project, I wrote a bindings visualizer because I give a lot of demos and I like to explain how everything is all wired up. So you can either upload an image, upload a zip file with your binding information, or point it to a GitHub repo, and it will visualize it for you, and it gives you an SVG that you can download.
That's cool.
So here, notice that we have a queue and a blob. It's showing document DB as output, even though it's both input and output. And our function is review image and text.
Got it. Cool.
So if you had a more complicated example, this is one that Chris Anderson has, which is an exponential scale sample, which it does exponential scale by creating 2 queue messages for each queue message that it received. So this actually will cost you a lot of money if you leave it running too long.
Yeah.
But you can see that even though it's doing a bunch of stuff, you can see that it has a queue, and the exponential scale function is what's creating all these queue messages.
Very cool.
So I recommend you use this. Go to functions-visualizer.azure websites.
We'll put it in the show notes.
Yeah. So let's go back to our code, and I'm going to set a breakpoint. So what I'm going to do now is, like I said, we need to moderate this. So people can put offensive words in the text.
Yep.
So we can use the the Cognitive Services content moderation APIs.
Oh yeah, cool.
And also the image analysis APIs, the vision APIs.
Oh yeah.
So we can look at the image, and if it doesn't have a cat in it, we'll say sorry.
No cat.
No go.
No go. Can't have that.
So what I'm going to do here is now F5, Now, remember, there's a queue message waiting for me because we just looked at it in Storage Explorer. So as soon as I run this, I should see my breakpoint being hit.
Oh, yeah, because we already uploaded the image that's running locally. So this is a nice way, essentially, of, at this point, the website's running locally, this is running locally, and essentially what you want to do is debug locally and then upload to Azure later, right?
Now, the cool thing is that you get to work independently of each other. So if someone else writes the web page, they get it all working, they're writing to Azure in their queue, and I can develop locally and make sure it works end to end.
Very nice.
So here we can see there's a new queue message detected, and the function is running.
Nice.
And it doesn't quite have it. There's a keyboard, I think, so it thinks it's a cat sitting in front of a laptop. But it's pretty close. But if we look and we see contains cat is true.
Whoa, cool.
And if we look at the result, what I'm doing is I'm using the description, and I look at the tags. And we can see here that, see, it has keyboard, mouse, kitchen, all these keywords. And so what I'm doing is, as long as cat is in the first 5 tags, then I will approve the image. And that was just kind of arbitrary.
Very cool.
So this is actually a printer. So I'm going to say a printer, and I'm going to add some exclamation points. Because I'm debugging, I can change the content.
Very
so
cool.
let's go to this review. We refresh. A cat sitting in front of a printer.
Nice. Very cool. And you didn't even have to do anything because it automatically just, boom, uploaded it. The website's looking at it, and then boom, it's done.
So now let's upload the monkeys again. I actually haven't seen how it will caption this, so this will be interesting.
Monkeys.
This is actually some cats. Let's try to confuse it. And the function triggers right away, and it tells us, wow, it's pretty accurate.
Whoa.
A group of stuffed animals sitting next to a teddy bear. So the monkeys look like a teddy bear.
That's pretty good.
So let's continue and refresh, and it's rejected, sorry.
Yeah. The beautiful part here is that literally these images could be coming from anywhere, whether it's from the website, from a mobile app, from somewhere else, who knows, right? Any IoT device that's sitting there taking photos over and over again that's analyzing this.
Absolutely.
And then literally nothing is happening on the phone or website. Everything is just happening in this function. And it spun up and then done. Just up and down and up and then done. And that's it.
If you get somebody putting, your app goes out in the store and it's really popular, you might get a lot of photos being uploaded. The function will scale up automatically.
Yeah. And the cool part here then is could you then take this photo at this point and then trigger the other Azure function to resize it when we're done? So can you chain these things together?
You could actually.
Say like only when approved, then resize it.
You could add a new queue message, for instance, to do that. The other thing you could do is tie this into a workflow using something like Logic Apps. So you could say, maybe if the confidence interval is not that high, let me cat's in the top 10 instead of top 5. You want to have a human approve it. So you could add, trigger a workflow, which actually sends an email to a human that clicks a button and approves the image.
Very cool. Awesome. All right, anything else you want to show us in this thing? This thing is amazing.
Let's just look at App Insights data.
Oh, sure. Because it's an app service, right?
Yes, exactly.
Technically, it's an app service, right? Ish?
Yes, actually.
Okay.
So if you look at your consumption plan in the portal, you'll see that it's an app service plan with a special SKU that is only able to be used by functions.
Got it.
But the way I did this is, so there's 2 things here. First off, if you just add an App Insights instrumentation key to any function app, you will automatically get our telemetry. So
maybe people don't even know what App Insights is.
Oh, that's a good question. Let's dig into. So Application Insights is a tool for monitoring your application, and it will show you all kinds of events, and you can filter on them to see how your app is performing. So once you've deployed it, you want to know, okay, what's going on? Is stuff working? Maybe you'll get some complaint from a customer who says it's not working. So what you could do is go into the analytics portal, and this is where the real power is. And here you can write queries with the SQL-like language, and it has a bunch of IntelliSense. So you can filter on the different properties. So here, our functions run a few times. So we should have the built-in metrics. So yeah, you can see the average duration, the max duration, number of successes and failures of the actual function running.
Oh, nice.
And then we have moderation result. This was a custom metric that we logged, which is super easy. So I just have basically 2 lines of code to log this.
Oh, cool.
So I have analyze review and then moderation result. So you can see here I have moderation result, and I say each time I log what's happening. So now suppose that you get a customer who's like, oh, I'm putting this image in, it's not working. This is when I did it. You could actually go in and see what's happening.
Oh, cool.
Maybe there's an exception. This will show you the exception. The other thing you can do is see how fast you're processing events and the server events and the failed requests. Here we don't have any failed requests. Then you can also see a dependency graph, which tells you how everything is all hooked up. So the website is calling into App Insights, which is calling to blob storage and queue storage, and you can see the latencies. And if there were any errors, here you would see, like, see here it says 0% failures. If there were failures, it would show you like an extra stack trace.
Cool, and then you could take, can you take that App Insights then? So I see this flow from mobile to functions to App Insights to monitor this entire backend. Can you then take that and put in like a Power BI and then do data visualization on it?
You can also do monitoring, App Insights monitoring on the mobile app as well, and then you could use a correlation ID for the request that you then pass to the backend. Let's say you're doing HTTP, that's the easiest case. You would pass in that ID to the backend or put in the queue message. So then you could look at a single request and see exactly what's happening.
Got it, cool. What does this function look like in the portal? Do you have it here? Like,
yes.
So, because we've just seen Visual Studio, what does it look like when it's actually in the portal itself, I guess?
So because it's a DLL, I have a different one that's also precompiled. But what it's going to show me is this my coder card sample, which is a Pokemon card generator.
Nice.
Which you could also do as a mobile app. You could have customers take a photo and then get a Pokemon card.
Oh, that'd be cool.
So if you look at here, we have our functions listed.
I see functions, proxies, and slots.
Right. So proxies are a way to route from
one place
to another. In fact, if we go to the site route, we've customized it to actually show a static web page that's hosted in Azure Storage. It'll just take a second because my function is cold. And so you can upload a photo.
Oh, cool.
Do I have any? I can upload a photo here.
Please.
There we go. Pictures. Oh, here we go. So we have Satya. And this will generate the function. I use a function to generate it, and we can look at our thing. We actually demoed this to him, which was fun. I wasn't in the demo, but my coworkers were. So where am I? So I want to go back to the function app that I was on.
There we go, yeah.
So slots are also a way to deploy. So you can deploy.
Like staging slots.
Exactly. That's exactly what it is.
The main function, are these each separate functions then?
Yes, so I have generate card, request image processing, and setting. So generate card is a queue trigger that then writes out to the output blob. You can see everything it's doing here. So because it's a DLL, it's not going to show me the DLL body itself.
Got it, that makes sense.
But I can go into monitor, and I can see that it ran recently. So this is like the built-in monitor view, but it's not as rich as application insights.
Got it.
So you can see it ran a minute ago, and it wrote to card output, so I could go and look if I wanted to.
Can you also have it, so in this card instance, right, it returned a card, and then can I await on the function? Let's say I make an HTTP trigger. Can I await for it to like come back then?
That's a very good question.
Yeah,
Let me
because
tell
how does
you
my
the answer.
mobile app know that it's done, I guess, is my question.
Well, there's two things you can do here, but the way the hottest way to do this is use durable.
New hotness.
So what you can do is do an async HTTP call with durable functions. So what happens is I think you can return a 201 with a location. So what you can do then is, what it does under the covers, you could do this yourself today. Under the covers, what this does is it automatically creates a queue message for you and a queue that you can trigger on. So what you do here is you can write an orchestrator function like this, and then you can await it. Like here, you can actually, if you want to call one function to have it call another, you wouldn't want a HTTP to call one function calling another because that's less durable.
Got it.
So here you can have one function call another, and under the covers it'll create a queue message for you. You can do fan in and fan out scenarios, or just one function calling another.
Cool.
So that's the way to do it.
All right, I definitely have to check that out. That makes sense, because that's what I'm kind of thinking is I want to take that photo and upload it, but then I want to get the results back and orchestrate that together.
Yeah,
cool.
Absolutely.
Awesome.
So that's what it looks like in the portal. But if you look at a function that's scripting, then you can actually edit that as well.
So these function apps contain multiple functions,
yes,
right?
Generally.
So you have a grouping, like this is my apps, functions,
Yes.
types of functionality.
So the rule of thumb is anything that you want to deploy together, you would put in one function app. It's kind of its own microservice.
Got it.
If you wanted to deploy one function separately from another, you would put them in separate apps.
Cool. Awesome.
So here, for instance, this one's C#. You could edit it in the portal because it's a script.
Oh, got
It's
it.
C# scripting.
So the scripting one, there's some different advantages
Yes.
and some disadvantages compared to the DLL, which we saw earlier. It's just the DLL that's being executed.
Yes, exactly.
Cool. Awesome, Don. This has been awesome.
Yeah.
I love it. So much awesome. So this is why I love Azure Functions. You can do crazy, ridiculous things with it, and then it costs you nothing, which is great.
Yes.
Which is awesome. Well, Donna, thank you so much for coming
Thank you.
on. I cannot wait to have you back on to talk about more Azure Functions.
Yes, absolutely, absolutely.
So until next time, I'm James Montemagno. This has been The Xamarin Show. Make sure you hit that subscribe button. It's over there or over there. Who knows where it's at? Hit it so you can keep up to date on all the latest and greatest happening. Until next time, thanks for watching.